It's time for Deepu K Sasidharan, if I am correct. And he will talk us about building a Kubernetes monitor dashboard in Rust. Why not? Thank you very much.
Thank you. Never got an applause before I start, so that's nice, very encouraging. So welcome and thanks for coming to this talk. Today I'm going to talk about why I built a Kubernetes dashboard in Rust. So I'm Deepu K Sasidharan. I'm the co-lead of JHipster, quite popular Java framework. I'm also a Java champion, created a bunch of open source tools, KDash being one of them. Open source developer, polyglot developer, author, speaker. I work as a developer advocate for Okta, focusing on the Auth0 product. I also blog frequently on my blog and also on the Auth0 Okta blogs. So if you're interested in any of this content, please do check that out. Interesting fact, I'm a Rust newbie, not a Rust expert or anything. I come from a heavy Java, JavaScript, Go, DevOps kind of background. And technically, this is the first Rust conference. I have done Rust talks, but not in Rust conference. So this is the first pure Rust conference that I'm doing. I normally do Java, DevOps, those kind of conferences. So again, thanks for coming to this talk. So first, let me introduce you to KDash. So KDash is a simple terminal dashboard for Kubernetes. It provides common resource views, node metrics, logs, and so on. I'll give you a quick demo. So this is what it looks like. The idea is to have a very minimalist or easy to navigate kind of UI. You can switch around just with your keys, like the arrow keys. You can tab around to different pages. You have context. You can switch context. You have a really nice utilization page for all your Kubernetes resources, your pods. You can group them around differently. You can view them differently and stuff like that. And in the context, you can switch. You can switch namespaces. You can do a lot of different filtering and stuff. It'll give you some useful informations. You can get into containers and you can get their logs, container logs, stuff like that. So this is what KDash does. So a lot more features. So you can check it out if you're interested. It's available on different platforms, Brew, Scoop, and all those things, or cargo install, or as a binary on the GitHub releases. So let me, yes. Okay. So why did I build a Kubernetes dashboard? Right? It's not like there are no Kubernetes dashboards available. There are many solutions available. There are a lot of Kubernetes dashboards available. And there is one specifically that might come to your mind if you're used to Kubernetes ecosystem, K9s. And obviously, this has a lot of similarities to that because this was definitely inspired by K9s. So when I started learning Rust, I actually wanted to build something more than a hello world and a sample application and stuff like that. I wanted to do something big to actually get in, learn the tropes, and try different aspects of programming in Rust. And I wanted to have a first-hand experience of Rust. So I was pondering with different ideas, and I was doing a lot of Kubernetes stuff. So I was using kubectl and K9s, back and forth, but I wanted something more than kubectl, but I also wanted something a bit more simpler than K9s, because K9s, it was a great tool. It has full CRUD on all your Kubernetes stuff, but the UX and navigation was a bit not for my taste. So I decided to build something similar, but maybe a simpler UX, easy to navigate, easy to remember, and stuff like that. So that's how KDash started. So then the question I normally get, because especially as a polyglot developer who comes from a heavy Java DevOps background, right? There is always the obvious question of why Rust and why not Golang, especially from DevOps people, because the DevOps world is heavy with Go. Most of the Kubernetes and DevOps tools are written in Go. A lot of Kubernetes stuff is in Go, although all of the Kubernetes ecosystem projects are mostly built in Go, right? So there is always this question that I get, and honestly, Go is an excellent language for that. It is simple, simple for SRE folks to get in as well. It doesn't have a complex learning curve. So there is no solid reason to choose Rust over Go for a project like KDash. Could have been built as good as this with Go, and probably the Rust version is definitely better in terms of speed and resource utilization. If you run them both, say you run K9s and KDash side by side, and if you look at your resource usage, you will see that this uses much less resource, even less than kubectl. If you run kubectl on a watch, it uses more resources than KDash in terms of memory and CPU. There is that, but that's not very important for a project like this. You are not going to get, even with that difference, it's not huge and it's not enough to affect your overall system performance or whatever. So it's not a big deal. Where I do see value of Rust is Kubernetes projects like sidecars, proxies, log aggregation or observability in Kubernetes clusters. So whenever you're putting something in a cluster along with your actual application as a sidecar, then I think writing that in Rust can make a difference in terms of how much you're going to spend more on overall. If you're going to attach a sidecar to all your resources, all your pods in Kubernetes, right? Wouldn't you rather have it in Rust where it is going to take as minimum, resources as possible than in Go? Because it is going to add up your overall cost, right? So that is where I would choose Rust over Go. Also for WebAssembly, right? For WebAssembly, especially WASI on Kubernetes, it's becoming a thing. So going containerless on Kubernetes is finally possible now. You can already use something like RustLab to write WASI applications for Kubernetes. And there are many projects like Wasm Edge and I think Wasmer and many others where you can actually start doing WASI for Kubernetes, where Rust makes a lot of sense. So the real reason I chose Rust for this, as I mentioned, was because I was fascinated with Rust and I wanted to do a POC to prove that user space project for the Kubernetes ecosystem or the DevOps ecosystem can be built using Rust. And the code base can be much more manageable than a Go code base, because if you look at the same code base, if you write it in Go and if you compare, then it's going to be like 3 times more lines of code in Go because of the repetition. Of course, with the generics, now it could be condensed a bit more, but I was able to do a lot of stuff that was done in K9s with much less code because of how I can structure it in Rust. And also, I didn't have to worry about a lot of things. I'll come to that later on. So this is the reason I actually kind of chose Rust. So as a polyglot developer, these are the things that initially attracted me towards Rust. A lot of this talk is going to sound like a love letter to Rust, so bear with me. I love the fact that Rust is a high-level multi-paradigm language, even though it was not marketed as such initially. It is a high-level language. And I like that you can do functional or imperative with Rust. And if you want to go full functional, I like the fact that you can actually do that in Rust better than any other functional language. I love the modern and, in my opinion, the best tooling that I have seen for any language. And I think I have worked with, more than a dozen languages in my career. And I've never seen a tooling ecosystem as good as that Rust has. The compiler, be it the cargo, be it Clippy, be it that entire ecosystem. It's so great. The user experience is so great that it has become hard for me to work on any other language and get that kind of joy. And I'm Java champion who goes out and talks about Java. I promote Java. I write about Java. I have written books about Java, and it is becoming harder for me to now go back and code in Java after doing Rust for a while. And it's like, okay, even whatever, Go, Java or JavaScript, it's becoming, I'm constantly missing that experience that I was getting because of that great ecosystem. Of course, it doesn't mean that everything is hunky-dory. There are some issues I faced. I'll come to that later. I also find I also like that Rust is finding footing outside of the systems programming niche, because when Rust came out and I started looking at it, I looked at it, it was like, okay, another systems programming language. I used to hate C++, and I was like, okay, maybe something similar to that. Okay, I'm not going to care about that, right? Then I saw like, okay, Rust is in embedded now. Okay, then it was like, okay, people are writing web apps. Okay, so you can write web apps. Then I started getting interested and I started exploring it, and I was like, holy shit, this is a general purpose language. You can basically do whatever you want. The only limitation is the ecosystem. So if the ecosystem improves, you can do that, right? For example, I won't probably use Rust to build a API server today. I would still do it in Java because it has a great ecosystem for that. But it's only a matter of time when the ecosystem catches up. For example, in Java, you have a lot of these ORM frameworks, right? If you want to do whatever database you want to work with, you will find great. You can use Hibernate, you can use whatever. You can use great ORM, you can work with your database, no issues, battle-tested libraries and ecosystem there. But you don't have that in Rust. If you want to work with databases, you have Diesel and few others, but they're not that great. If you have tried both, you will know what I'm talking about. They're not that great, right? But it's only a matter of time when they catch up, and when that ecosystem is there, it's going to be hard for people to ignore Rust in those areas as well. I would, if I'm a betting man, I would say that maybe 5 years down the line, Rust would be as equally considered for API servers and web servers. Probably not for very user-facing applications, but at least as microservices and stuff like that. And as the saying goes, I came for the compiler, but stayed for the community. But apart from these obvious reasons, there are a few things I considered unique, and the reason why I chose Rust. Before that, how many of you are Rust developers or Rust newbies? Okay, how many of you are Rust experts? I have to. So what are the other people then? Rust, medium Rust developers. Okay, no, because I'm going to gauge how much I need to talk about these things, because otherwise it might be either too boring or too less details. Because I normally do this talk in a Java conference. I get weird looks. So then I can explain a lot more. But among Rust developers, this might be okay. We all know this stuff, right? So, and also keep in mind, this is coming from, again, someone with a strong Java background. I'm a Rust newbie. I started doing Rust like maybe 2 years ago, seriously, maybe 1 year ago, between 1 and 2 years. And that is when I fell in love with it and started doing more of Rust evangelism, what I would call. So bear with me if some things are, same to you. So I really like the buzzwords used by Rust. We are used to buzzwords, right? And that is why my role came, like developer advocates as a role came about, because we developers became annoyed with marketing buzzwords, right? So we had to find a new way to market to developers by becoming advocates and talking non-buzzwordy language and stuff like that. But I really like the buzzwords that Rust uses, because I think they really mean that. It's not just like marketing bluff, right? They really mean every buzzword that they use. So I really like those. And of course, the ownership and memory management in Rust is what makes it special, in my opinion. And I appreciate that a lot more coming from garbage collected languages. I love that I'm getting the efficiency and speed of C++, because I hate C++ because of its unsafe thing and the number of CVEs that it causes. I also happen to work in cybersecurity domain, so I hate that there are so many security issues that is caused by people, because C++ lets you do that, and I like the fact that Rust gives you that kind of safety, but without the overhead that, runtime overhead like Java or Go in terms of garbage collection. So I really appreciate that. I also appreciate the safety guarantee that Rust is providing. I think especially the thread safety and null safety. Any Java developers here? Or ex-Java developers? I think you all know what I'm talking about. The working with threads in Java. If you have worked with threads in Java, you know how it works. It is, once you have done it, it works. It is solid and everything. But to get that working, that part when you do it, it's not that great of a experience, right? Synchronizing and all that. It's so much headache, so much things that you have to do yourself. And after doing threading, a lot of multi-threading in KDash, I was like, I at some point I forgot that I'm doing multi-threaded applications. I didn't have to worry about it. I didn't have to worry about designing it for a multi-threaded application. In Java and other languages, you have to worry about that. Even in Go, with Go routines is great, but you still have to worry about how you design your data structures. You still have to worry about data races or accidentally introducing something. But I didn't have to worry about that. And whenever I was messing it up, the compiler was like, hey, you can't do that. So I really enjoyed that. I think the Java folks would understand what I'm talking about. And of course, memory safety. Whenever I talk about Rust memory safety, especially to non-Rust folks, I often get this question, but are in most high-level languages memory safe, right? And my answer would be sort of like, of course, not counting C++, which are unsafe. But even the memory safe languages like Java, Golang, or C#, you will still occasionally get some issues related to that, like memory leaks. In Java world, it is getting less and less common now, but at least 10 years ago, memory leaks were a common thing in the Java world. You'd get some, suddenly you'll see your application using up all the resources, and then you start investigating, okay, there is a memory leak. And buffer overflows. These were quite common in these languages. Of course, probably not as common in Go, but in Java and C#, they were quite common. So I like that, you don't have to worry about, of course, I know that you can introduce those kind of issues in Rust as well if you really try. But the fact that it is harder to do that is what makes the difference for me. So I was so excited when Rust officially became supported as a language in Linux, because I was dreaming of, okay, I really wanted to, I'm a huge Linux fan. I use Linux for everything. And I really wanted to contribute to Linux, but my barrier of entry was the language. I looked at the code and I was like, no, not going. I don't want to do anything with this. So when Rust became an officially supported language, I started getting excited. And I'm like, maybe, finally, it is getting close. I can finally start contributing to Linux maybe, but in Rust. So that is an exciting thing. And null safety. Maybe Rust folks, you don't consider this a big deal, but someone coming from Java, this is a huge deal for me. Null pointer exceptions has been like a nemesis of Java developers, right? It's like, I don't even know the number of times I have had null pointer exceptions in runtime. Like, go find out what is it. At least now in Java, we have the error says which was null. Was not the case back a few years ago. You have to go find out from all things, okay, what was null? It's like, it's always like, okay, this was null. Okay. So I like that you don't have the concept of null in Rust and there is only optional monads. It's really nice. Something I really appreciate was that. And threat safety, man, Rust guarantees, the threat safety that Rust guarantees is like phenomenal. And I like the fact that you can use channels, mutex, arcs, or whatever, and you still get threat safety. And again, as I mentioned, as someone coming from the other languages, where you have to kind of think about threat safety, even though the languages says they're threat safe, you still have to worry about data races, you still have to worry about data locking and stuff like that. This working in Rust was like, it was so great. I ended up using so much concurrency in KDash, even though I didn't have to, because I could without worrying about it. So I was like using concurrency for, I was like, okay, a new thread. Like by the time I was done, I was like, okay, I was using 7-8 threads. And I'm like, actually, I don't need these many threads. Hey, I could do it. I didn't have to worry about it. Didn't have any issues with it. It's working beautifully. So yeah, I'm going to keep it. So, and it was not causing any more memory usage or more resources. It was like, awesome, this is cool. This is what every developer wants. Working on all these things without having to worry about, how to structure that or how it is going to affect your data structure, or how if it is going to affect if it is going to cause data races or whatever, right? So it's just phenomenal. I do miss user mode threads like coroutines, which are simpler to use for simpler use cases. I do miss that in Rust, but I see that there are some works being done for that. Maybe in the future we'll have something similar to coroutines in Rust, hopefully. And the my most favorite feature of Rust is hands down zero cost abstraction. I think it is also the most underrated and most underappreciated feature in Rust. I don't know how many of you appreciate this feature. I really appreciate that. And I can't stress whenever I talk to people, this is the first thing I talk about. I can't stress how cool it is. Like, especially if you're doing a lot of functional style programming, right? The more abstractions you create, the more stack frames you are creating, the more instruction sets you are creating, slowly you are decreasing the performance of the overall thing. So the more functional you write in a non-zero cost abstraction language, the more performance you are paying. Even though it might be negligible in the grander scheme of things, you're not still writing the most performant code. Of course, it doesn't matter for every program, because some programs can, not every program needs to be the most performant, right? But in cases you need that, and if you decide to do functional programming for that, then you are going to pay in performance penalty. And I like the fact that with Rust, you can do full functional and don't have to worry too much about that, because it is still going to, because most of the internal like Rust iterators offers zero cost abstractions, right? The async thing offers zero cost abstractions. The ownership and borrowing thing, zero cost abstraction. So I like that you don't have to worry about that, and you can go full functional or whatever style of programming you write with whatever abstractions, and you don't have to care about your programming style to dictate how it will perform. So I really like that aspect. So of course, many other languages also have compilers which are smart enough sometimes to optimize code, but I don't think any, at least I haven't seen any compiler that can be as smart as Rust in terms of optimizing your code to the best possible code. So much so that you cannot hand code it better, right? And so I was doing some benchmarks. I think may not be very visible at the end because of the light. So the one on the left side is the Java code I wrote. So I wrote some simple factorials in every way possible in Java. So with Java, I did one with iterative approach, imperative for loop, and I did one with recursion, and I did one with the functional approach using the Java Stream APIs. And I did the same in Rust as well, using these three approaches. And in the Java one, as I expected, the imperative approach was the fastest, followed by the recursive approach, and finally the functional approach was the slowest. It was, I think, 2 or 3 times, 2 times slower, or 2 times or more slower than the imperative approach. But that is expected, because in the Java world, when we have to optimize something for performance, the first thing we do is we turn it into imperative code. So the more imperative you make, the more performant it becomes. So that's like a known thing. And I think that's true for most languages, right? Where if you have to squeeze out the maximum performance possible, the final step is you go imperative, right? If you can't go machine code, then you go imperative. That is the closest you can get to machine code in terms of performance, right? But in Rust, I was surprised when I did the benchmark. I was so surprised that the functional approach was the most performant. It was like, I think, slightly more performant than imperative and the recursive approach. Recursive and imperative were similar. Functional was faster, and I was like, hey, that doesn't look right? So I rechecked the code. I reran this. It's the same. I reran it like 5-6 times, and I couldn't believe it. Then I started looking up about why is functional Rust faster than imperative Rust. Then I started seeing these threads on the forum, discussions about, okay, the iterator implementation does bound checks for arrays and stuff like that. There is some unsafe magic going on under the hood to optimize it even further. Okay, that makes sense for the difference in performance. So probably if you do similar in your imperative approach, you'll also get similar performance. But the point is, regardless of the style, you're getting similar performance, and using the inbuilt iterators or functional implementations is actually giving you better performance than what you would hand code imperatively. So you don't have to actually worry about hand coding, and you don't have to worry about, when you write code, you don't have to worry about making it coding in a way that is the most performance. You can just code as you like, and the compiler will do that for you. So that is great for most programmers, especially people who are learning and people who are getting into the language. That is one pain point that you don't have to think about. Of course, Rust has a huge learning curve. I'll talk about that after I finish this. And there are, of course, I also appreciate the immutability aspect of Rust. I appreciate that it is immutable by default. Pattern matching, great pattern matching that I have tried in different languages, and it's really good. I like the generics traits and stuff. Of course, the lifetimes, it was quite difficult in the beginning, but I think each version of Rust is making that simpler. So with each version, I'm even able to remove some lifetime annotations from my code because it is inferring that much better now. So that is becoming much more nicer. Macros. The macros are a great feature. Of course, sometimes it kind of feels like cheating because you can do anything that you cannot do normally with a macro. It feels like cheating, but in the end, it is being compiled. And if the compiler tells it is okay, I'm going to trust the compiler there. So, and finally, one of the greatest communities that I have seen in terms of the diversity of the community. I don't think I have ever been in a community forum where I would post a question and immediately get a response in any other language. The Rust community has been like, whoa, I can post something. Normally you go to Stack Overflow for those things, but for Rust, it is better to post on the Rust community forum than on Stack Overflow because you get faster answers. And the community is very welcoming and never had any stuff that you get from some language communities where it is very academic and hey, we're all smart people. When there are new people coming and approaching, they're like, oh, this might be too much for you, kind of thing. I don't see that in Rust, which is very nice for beginners to attract more people. That might also be another reason why more and more people are getting attracted and coming to Rust because of that openness and inclusiveness. So it is great. And as I mentioned, great tooling and ecosystem, growing ecosystem. Of course, wasn't a cakewalk. I did struggle with some stuff. Of course, I think for me, being a polyglot developer was helpful because I was already used to like a dozen of languages, so I could transfer the knowledge of a lot of concepts like just directly, because Rust also kind of felt like an amalgamation of multiple languages. I was seeing a lot of concepts that I was familiar in the JavaScript world. I was seeing some concepts from say .NET, some from Java, or some from Python, some from Go. So I was seeing all these concepts that I was already familiar with, so that was easier, but still was there was difficulties. The learning curve, I think, is still a bit steep, but I think it's becoming better now with more and more language features being kind of optional, like lifetimes being simplified and stuff. I think one of the biggest hurdle for me initially was understanding the memory model, and working around or trying to figure out, hey, how I can declare a variable, but I need that variable passed to this function, and I need it here. How can I make it in a way that I get that lifetime until there? Then I try some things. It was mostly trial and error. Then the compiler just yells at you, so it is wrong. So that is a good thing, that compiler doesn't let you do wrong stuff, right? So it is wrong. I would rather know something is wrong than try to correct it. So that was a nice learning experience. So again, I think the learning was a bit difficult in the beginning, but it was the right mix of challenging and intriguing, so that it was not a blocker, so that you don't throw it and okay, this is not going to work, you don't go away. You were intrigued enough and it was challenging enough, so you keep going and you get past that curve. And I think after I passed that curve, then it was easy. It was like working with any other language. I think that took like 1 or 2 weeks for that curve to pass. So, and of course, it being young and maturing, finding libraries for stuff was a bit difficult, especially for certain use cases. I don't think building web applications in Rust is still that great of an experience, because the library ecosystem is not that great. You're not going to find libraries for most things. So I was trying to build a sample application for Auth0 for OIDC, and I was like, I wanted to do a Rocket version, and I was like, I wanted to use the latest Rocket version, but then there is no OIDC library that would work with that. The ones that would work is for the older version. So that ecosystem is still maturing, I would say. It's not there yet, but I think for systems programming and embedded, I think the ecosystem seems to be quite good. Also, I'm not a fan of many ways to do the same thing, kind of like in the Scala world, also in the JavaScript world. Of course, it doesn't matter because of the zero cost abstraction, but it is still a bit of a problem, especially if you're working in bigger teams, because everyone could write the same thing in a different way, and then you have to learn all these ways to do this thing to understand that. That is one thing I like about Go, because there are not many ways to do the same thing. So if you're writing Go code, any Go developer can understand your code. You don't have to you don't have to know everything about the language to understand. You just need to know that basics and you'll understand. And I think Scala had that problem of too many ways to do the thing, and like every code base looks like a different language, and like, like C++ or whatever. So I think Rust also has a little bit of that problem. I hope it doesn't go too much towards that, adding even more ways to do the same things. I think we already have enough ways to do things, so would be good to just be at this level, not go overboard with that. With all this, I think from my experience at least, Rust is definitely the closest thing to a perfect general purpose language, in my opinion. Doesn't mean I'll be, as I mentioned, it doesn't mean I'll be doing only Rust development, going forward. If I'm building a web app or an API server, I'm still going to do it in Java or Golang. But if it is something like, building a CLI or a systems app or embedded or WebAssembly, I'm going to prefer Rust over Go or other things. Yeah. So I really like this. I read it in a Tech Republic article, and that was really well said. I think Rust is Mozilla's biggest contribution to the world, not Firefox or anything. I think this is the biggest contribution that they have made. And I do encounter a lot of Rust skeptics. Even I was talking to someone last week, another Java guy, and he was not buying into anything of Rust. And we had this huge discussion. And I was telling you won't appreciate, because I used to be that guy. So when I heard about Rust, I was like not very interested. I used to have these kind of discussion with other folks. I had a friend who was doing Rust, and he was like, "Hey man, you need to try this out. This is great." And I was like, "Yeah, but you have these superficial arguments and stuff like that." But then I tried it, and I saw what he meant. So once I tried it, I couldn't say otherwise, and it would be wrong for me to go and say otherwise, right? So I keep telling people, you won't appreciate Rust unless you spend few weeks building something in it. Initially, it might be a bit difficult, but once you get past that point, then you won't go back. Also like that, normally with every language, I think any language you take, you get to pick two of these. You get to pick either safety and speed, or speed and abstractions, or safety and abstractions, not all three. I think Rust is the only language that I have seen that offers these three. I heard someone saying Zig also gives three, but I haven't tried Zig yet, so I cannot know for sure, but Rust gives you all three. So enough with my love letter to Rust. Hopefully that was not boring for most of you who are Rust experts. So a little bit more about KDash. I used a bunch of libraries, and I highly recommend these libraries if you have similar use cases. I have some time to talk about them. Yes. So the first two, so they work together. 2ARS and Crossterm. Probably you're familiar with Crossterm. So they work together. Excellent library to build anything on the CLI, like any kind of UI on a CLI. Really, really great library. Very well done. Very well architected, and very easy to use. I think I spent probably like an hour looking at the docs, and it was like, okay, so simple to get in and use, right? And beautiful results. Of course, Tokyo, I think everyone uses Tokyo these days. Probably it should be standard library at some point. And if you're in the Kubernetes ecosystem, then there is KubeRS, which is a Rust implementation of the Kubernetes client. Not as feature, it doesn't have feature parity with Go, but they have some clever traits which kind of bridges that gap. So whatever you don't find, they have some clever traits you can use to kind of just add that yourself with few lines of code. So that was like awesome. So I was not having the metric server implementation part, and I was like, okay, hey, there is this. And I was like asking them, how can I do? Can you add the metric server implementation? They're like, yeah, but we have this trait, you add these 3 lines and you get it. I'm like, wow, that's so cool. So they have some clever implementations for that. So it's getting better and better. It has some issues, especially when it comes to log streaming and stuff. I think because of some limitations with how it is done, I think underneath, or maybe because it was designed with Go routines in mind and doesn't exactly work that way with async on the Rust land. Maybe I haven't explored a lot because I still have some issues with the log streaming. And I use a few other libraries, like smaller libraries. Smaller libraries for serialization, command line arguments and stuff like that. And kubectl view allocations if you want that nice resource allocations as a standalone thing. So I did have some trouble with the Rust clipboard, especially on ARM and ARch architectures. I'll talk a little bit about that struggles. In terms of data architecture, initially I was just trying to do something that I would do in Java or Go. I was trying to do it in the similar way, but then I think halfway through I rewrote the entire thing because I realized, hey, with Rust I can do much more. I can go full multi-threaded without having to worry about anything, and I can just play around. So kind of went full multi-threaded and went full async on it. So it's completely event-driven using channels. Have a single data store. Use Arc Mutex to kind of share that data among the threads. Separate threads for UI, streams, network, and everything. Started with the blocking UI, but I soon realized that okay, that's not going to work because whenever there was network requests, the UI was frozen. So that is when I started splitting into different threads. Then I ended up splitting everything into different threads. So I did face some challenges, as I mentioned. Apart from the learning and understanding aspect, which I really liked because it was very rewarding in the end. Most notable challenges I had was streaming logs, which was very challenging to do that. I don't think I still got it right. It works, but there are still some glitches and issues. I would like to revisit and rewrite it at some point. So if anyone is interested in helping me out with the streaming log implementation, feel free to do so, because I don't think I'm still that good understanding every aspect of Tokyo, especially because when it comes to streaming, there are a lot of plugins in Tokyo that you end up using. I'm not very good at all the pinning and all those aspects of Rust yet. So I'm having some trouble there. Kind of made it work, but I don't think that's the best implementation. I think I tried moving it around to new threads. It fixed some problems. I started using Tokyo streams. That fixed some issues, but still there are some issues there. As I mentioned, there was UI issues, which was due to using same thread for network and rendering UI. So splitting them into two threads was a no-brainer for that. So I had a lot of trouble debugging, especially I think when I started this project, I was using VS Code. The debugging in VS Code, I think that is the only aspect of the Rust tooling that still needs to be better, the debugging aspect, because I think I was using the CPP something for debugging in VS Code. Sometimes it was glitchy. Sometimes you will end up having objects with only addresses, you can't look at the values and stuff. Sometimes it will go into machine code and just show assembly code. I'm like, okay, what am I supposed to debug with assembly code and stuff like that? This is getting better, but it was some issues. Had a lot of trouble setting up a CI and builds for this. So because I think that probably because I don't have a lot of experience building user space applications. Most of my experience was in web applications and API servers and that kind of stuff. So building for different architectures, especially Muscle and ARM and ARch, was very challenging because having to have the right libraries set up in the Docker image, having to consider the right libraries that works with the right architectures and stuff. Then I found out that Rust clipboard doesn't work on ARM and ARch. But thankfully, I really liked the CFG macros where I could just skip the functionality for those architectures. So I use those to kind of skip the copy functionality for those architectures as an interim solution, because I couldn't find a library that would work across architectures. So probably another option would be to use two libraries, one for these architectures and one for another. Maybe there are better options. And finally, there was some issues when using a library. When using a library in your application, and the library also uses a library that you use. So you have two versions of the same library. And then I had some issues when there were two versions of the same library in the same thing. Especially, I don't think it is a Rust problem per se. I think it is more probably the way that library has been set up. It is the Kubernetes KubeRS library. It seems like you cannot use two versions of KubeRS in the same project without some playing around, without some workarounds. So I did some workarounds. Still a bit annoying because every time I need to update this library, I normally go PR the other library also to update them, so that compiler. Otherwise, the compiler just ends up complaining that there are two versions. And I think the check is done at the library as well for this, so it's kind of a library issue, not a Rust issue. If someone has nice solutions for these kind of issues, do let me know. Thank you. So I think I'm done with my love letter. So that was it. I also built a game using the same TUI, RS and cross term. So it was really easy to do. I already had this game in Java, so I kind of rewrote it in Rust. So if you want to check it out. So thank you.